All right, let's go over the Doppler questions from the sound chapter that we're studying. Down here, I've written down a couple of formulas that we need, and the speed of sound in air, 343 meters per second. I'm using FO to represent the observed frequency, FE for the source, V is the velocity of the object, VS is the speed of sound. And we have two cases here. This first one is if the sound is moving. Well, I mean the source of the sound is moving. And right here, this other one, if the observer is moving. All right, so a train honks a horn as it approaches the train station. The horn is 655 hertz, and the train is traveling at 21 meters per second. What is the frequency heard by the observer at the train station as it approaches and moves away? So we're going to use this formula down here at the bottom left. And we're going to use it twice, once for approaching and once for it leaving. So the observed frequency is going to be 655 all over 1 minus, because it is approaching, let's make that a clear minus, the velocity of the train, 21, all over 343. And we can put this all in our calculator, but we want to make sure that we put this portion especially in parentheses. So let's take a look right here and see. So I'm going to have 655 all over 1 minus 21 over 343. And that's 697 hertz. Okay, so we do expect that as an object is coming to have a higher frequency, and as it is passing to be a lower frequency. So now for the other portion, we add if it is going away. So we did as it approaches. Now we'll do as it's going away. So 21 over 343. So it's just a slight change in our formula. And so I'll go over here onto the calculator and just change the sign to a plus. Switch that to a fraction, and 16 or 617. All right, so that one's all done, cleared up. We'll keep the formulas there at the bottom. Let's go on to the next question. So while sitting on the porch, you watch a cop coming down the road with his siren on. So the sound source is moving. As he passes, you estimate his speed is 25 meters per second. The sound you hear is 60 hertz. What is the actual emitted frequency for the siren? So we're going to use this formula. It says as he passes, so he is moving away. So we're going to have 600. That's our observed frequency. Emitted frequency is what we're looking for. We don't know that. So 1 plus or minus V over Vs. So we're going to say 600 equals our emitted. 1, it is going to be it's passing, so it's going to be a plus. The velocity of the cop is 25, and the speed of sound is 343. So I'm going to do all of this bottom portion on the calculator, and now I'll continue my work up here. So we'll have 600 equals FE all over. I'm going to put this over 1 because in a minute we're going to cross multiply. So I'm just going to do that bottom portion, 1 plus 25 all over 343. I'm going to want to keep a significant number of these decimal places because I'm not at the rounding stage yet. So 1.073. Now we'll cross multiply. So I'm going to get FE equals, because 1 times FE, and then multiply by 600. So times 600. And I get 43.7, so 644 hertz is what was actually emitted. So you just basically substitute in the formula, as is the case in most physics, and go ahead and simplify or solve. While riding a bike at 11 meters per second, you approach and pass a musician who plays a tone at 440 hertz. What is the frequency you hear as you approach and move away from the musician? So this time, I'm going to be using this formula right here because you are the observer. You're the observer and you're the one moving. So FO equals FE, 1 plus or minus V over Vs. And you're the one moving. Our emitted frequency is 440. Now it is going to be a plus for approaching because it's opposite of the other formula. So our velocity is 11 all over 343. We'll go ahead and type that in. We'll want to just be careful how we type it. All right, and 454. So a little bit higher. You're also not going that fast. And now as we move away, so we just did the as we approach. Now we're going to do as we move away. Same formula. And this time it's going to be a minus. And I'll just go to the calculator here and just switch that one sign from a plus to a minus. And we get 426. All right, you ride your bike at 15 meters per second and notice a thief. Apparently it's Jill. Good job, Jill. Breaking into Joanna's car. The alarm goes off and you hear a pitch of 375 hertz. That's a pretty low pitch sound. What is the actual pitch of the alarm? So again, you're the one moving. So we're going to use this formula, and it says you're riding your bike, and you notice it doesn't ever say whether we're approaching. We're going to assume that you're approaching. All right, so we'll have 375 equals, because that's what we observed. So in this case, we observed the 375. We want to know what the actual pitch was. And since we are approaching, our velocity is 15 all over 343. And we'll go ahead and do that portion that's in the parentheses. And again, we'll want to keep a significant number of these decimal places because we aren't quite ready to round. So we get 1.044. Now we're going to divide by the 1.044. So 375 divided by 1.044. And we get 359. And that's what we would expect. If we're approaching, it should be getting louder. So I think that wraps it up for this. We do need to keep in mind for this formula right here, we use this one if the source is moving. So this one, the source is moving. And for this one, we use the minus for approach, and we use the plus for going away. And this other formula is if the observer is moving. And we use the plus for approach. And we use the minus if we are the observer and we're moving away. So pretty simple to use them. Just plug in the numbers and solve.